Hey guys, welcome back to our channel Thinking Code. Hope you are doing well. So, as previously we discussed about C-style typecasting, which mainly focuses on C language. From this video, we are going to discuss about different types of typecasting designed only for C++. So, there are many typecasting present in C++, but today we are going to discuss specially on one of the typecasting, which is static typecasting. So, what you'll get to know in this video is like why we prefer static cast over C-style typecasting? Like why we have already C-style typecasting, right? Then what is the need for static casting in C++? So what static cast is actually and how static cast internally works, like syntax and everything. And when static cast does not work, like there are some cases static cast does not work. So we will see these all cases, what actually happens and where it doesn't work, how it internally works, everything. So so let's quickly dive into the first question. Why we prefer static cast over C-style casting in C++? So generally, what generally C++ beginners do is they use C-style typecasting in C++. So here what actually happens is C++ doesn't throw any error if you use C-style typecasting. If there is unsafe typecasting done or dangerous typecasting done, it doesn't throw compile time error. But the beginners may face issue at the runtime. We may face runtime errors and we may get some bugs which may be unidentifiable. So to overcome that, we have static cast. So these are the three main advantages of static cast. It is type safe and check that compile time. So what actually static cache does is it mainly focuses at compile time errors. Like what I have said, beginners in C-style typecasting, we don't get compile time errors and we will face problem at runtime, right? So here to overcome that, what static cache does is it throws the compile time error so that we can understand it, we can modify the code and we doesn't face any problem at runtime. And it has clear and readable syntax and it prevents unsafe conversions. Unsafe conversions are prevented in static as well. So we will check it by seeing the example. So here I have the code. Sorry. So this is the general typecasting in C style in C language. So what actually happens here? We have integer variable, and I am modifying it. I am typecasting it to the float variable, assigning to the float variable. It is safe, and we'll get the output. See, didn't get any error, and we got the output as 10, right? So So that is the case. This is valid case. It is valid in C style typecasting. So in C style typecasting, I will show you something which is dangerous, and to overcome these dangerous cases, we use static cast. So this is one case. What actually happens is this is we have integer variable here, and we are assigning integer pointer to it. It is safe. Assigning integer variable to integer pointer. Now what I am doing is I am forcefully telling the compiler to convert the integer pointer which is pointing to integer variable. This integer pointer is pointing to integer variable, and I am telling the compiler to convert the integer pointer to float and assigning it to the float variable, float pointer. So what actually happens when you dereference the integer pointer, it will dereference in the integer type. But when you dereference in the float pointer will dereference as if it is a float variable. Like float variables will have sign, mantissa, and exponent, right? So according to that, it dereferences and it gives the output. So now let's check the output. What we will get it. According to the estimated output, we need to get 100 as the answer, right? So there are no errors. See, observe it. You didn't get any error, but you may get different output, undesired output. Actually, you need to get 100 here, but this is the undesired output, something garbage value we have got it. Why did we get it? Because compiler mainly focus, if you dereference a float pointer, it mainly focuses on float type. It will dereference as if it is a float variable, but it is dereferencing integer variable actually. Who is dereferencing it? It is dereferencing float variable, float pointer, so that you are getting the garbage value. So this is one case where it is unsafe, but we didn't get any compile time error. And another case is this, like we have character variable and we are assigning character pointer. Again, same case. And now again I am telling compiler forcefully to convert the character pointer into integer type and assigning this character pointer to the integer pointer. Now again I am printing it, dereferencing the integer pointer. So what actually happens is, so now character pointer will point to only this one memory, right? One byte of memory. So this will point to this one byte of memory. If I dereference using this character pointer, I will get the output as 44. Okay, it's okay. But now I have told the compiler to forcefully convert it to integer type. So when I dereference the integer pointer, what actually happens? It will
totally use these 4 bytes of memory and dereference it. The data present in these 4 bytes of memory will be dereferenced and you will get the output. These 3 bytes are not important for you because your main reason is to print the character 1 byte. But these 3 bytes will also get printed. And if you modify using the integer pointer, the whole data will be modified. These 4 bytes will be modified, and these 3 bytes are not much important for you. This may be an important data type for data for you, but it will also get modified. So at the runtime, you may get error for you. So now see, now I am dereferencing using integer pointer. You need to get the character B, but we didn't. We have got the output as C here. We have got the output as 2566 something. So this is the garbage value. So what actually happens is this is the main thing. We didn't get any compilation error, and we are getting undefined output, undesired output. So these are the main cases. Here also we are dereferencing the float pointer. We have got undesired output. Here also we got the undesired output. So this is the main disadvantage of C style typecasting in C++. In C language you may get it, but in C style, in C++ you will get the different output. So to overcome this, we use static typecasting.
Now, what is static cast? What actually static cast is? Static cast is a C++ typecasting operator. It is a typecasting operator, not a function call. It is a typecasting operator used for safe and explicit conversion that is checked at compile time. So mainly static cast mainly focuses on compile time.
As we have got to know that in C time, in C style casting, we didn't get any errors. Even if it is unsafe or dangerous type casting, we didn't get any errors at compile time. So this static cache, what actually does it gives error at compile time only. So the syntax of static cache is like this. You need to use keyword static cache, static underscore cache, and here you need to write the target type and here the expression. So here I will explain you in the form of code what actually it is. So this is the basic example to explain you what actually static cache is. So here,
See, this is the syntax. We have used the keyword static underscore cache and here double and x. So here I have taken the integer variable and I am converting this integer variable into the double.
so here target type is you need to convert it to double, and what you are converting your expression. It may be the expression or it may be the variable. This x you are converting into double type and I am assigning it to the double variable. So this is okay. This doesn't give any error and it compiles successfully. See, I am compiling it. See, I didn't get any error and I am checking it. See, I got the output 10. So this is the basic case how it runs, how static cache runs. Now let's check it. How static cache internally works. How static cache internally works is see what actually happens. So I have said you like in C style casting.
In C style casting, we didn't get any error and
We got runtime errors, right? So now here how we will check it. So this is the same example we have done using C style casting. Here is a character variable and we have assigned it to the character pointer. So now we are forcefully trying to convert the character pointer into integer pointer. Now this is the character pointer. Compiler knows that this is a character pointer, but it doesn't know for which data type it is pointing. Compiler mainly what actually happens in compile time and runtime is compiler mainly focuses on what type of pointer it is, but compiler doesn't focus on to which data type it is pointing. So here CP is a character pointer. Now compiler knows that this is a character pointer. Now again we are converting it to the integer pointer. So this is the dangerous case, right? So due to this, what actually happens? See, this character pointer is pointing to integer pointer, converting into integer pointer. Now I'm assigning this after converting it. I'm assigning to the integer pointer. So now see, it gives the error. Why it gives the error?
here we got the error. Why we got the error? Because is so this character pointer will point to only one type.
One byte of memory, right? But integer pointer will point to whole 4 bytes of memory. So these 4 bytes of memory, remaining 3 bytes of memory may be important data. So if we use it, it may be bug or it may give you any undefined behavior. Or if you try to change the change using integer pointer, those remaining 3 bytes of data will also get changed. So this is a bug, or this will give you runtime undefined behavior at runtime. So for that, this static cache, what actually it has done, it has given us error. So now let's see another case. I'll show you another case where actually static cache fails. So this is the case where actually static cache fails. Uh, so see now this is the double.
So now here we have double variable which is 3.14 double variable I have taken
And here I have assigned the address of double variable to the void pointer. As you all know, void pointer is a generic pointer. It can point to any data type. Now what I'm doing is I'm taking this void pointer and forcefully telling the compiler to convert it into integer type. So after converting it, I'm assigning it to the integer pointer. So what actually happens now? If I dereference it, will I get the output or not? Let's check it, because void pointer converting to integer type, and we are checking it. We didn't get any error. At compilation time, we didn't get any error. You observe it clearly. We didn't get any error. Now I'm checking the output. Now we didn't get we got undesired output. Didn't get any error, and we got undesired output. Why we got undesired output? Here, see, it is a double variable actually. Double variable, and we are dereferencing using integer pointer. A double variable dereferencing using integer pointer. So if you need to understand this, first you need to understand what happens at compile time and runtime. So at compile time, what actually compiler thinks is, compiler mainly focuses on what type of pointer it is. It is a void pointer. So void pointer, okay, void pointer can point to any data type. So what compiler thinks, as it is a void pointer, it is true. Compiler doesn't think that at what data type it is pointing. It mainly what data type it is pointing is done at runtime. This void pointer is pointing to double. It This is mainly focused at runtime for which kind of data type it is pointing. But compiler mainly focuses on it is a what type of pointer, void pointer. Done. It is converted to integer pointer. Generally, void pointer can convert to any type of data type. So this is true. So for this, what actually happens is, as static cast is limited to compile time, and compile doesn't throw any error. Why? Because void pointer typecasting into integer. It is true. It will be typecasted, and we are dereferencing it. We will get undesired output, however, because the dereference what we are doing, it is not good, because double is of 8 bytes and integer pointer can point to only 4 bytes. So due to that, we are getting undesired output. So for that, this is the main thing. The static cast is limited to compile time only. So for that, we didn't get any compile time error, and at the runtime we are getting undesired output.
So here I have one more interesting example. Let's go through it. So what see, observe clearly about this example. See, don't get panic. Just observe it simply. Don't observe this commented section. See here I have a class with name my class. I have a private data type value. I have default constructor. Now don't observe these all parts. So in the main section, what actually I'm doing is I have an integer variable 10. This is okay, integer variable. And I'm creating the object obj2 for my class. And what I'm doing, I'm assigning this integer data type to this object.
Is it valid? It is not valid actually, because it is of integer type and this is object is of my class type. So these two doesn't work. And I again what I'm doing vice versa. This object I'm assigning to the integer data type. So two different data types, operation doing on two different data types is not valid. Let's say we'll get the error or not, or will it works or not.
See, see, we got the error. Conversion from int to my class. Again, convert from my class to int. These both are not possible. So generally, what we'll think, if it is not working, generally we will go for typecasting.
So first let's check for C style typecasting here. Now what we'll do in C style typecasting, same in brackets. Again we need to write my class.
Okay, this is okay. And for here again, same C style typecasting. And in bracket, we need to write int. So this is C style. This x1 is converting into my class and assigning to my class object.
And this obj, which is of my class data type, we are converting it to integer type and we are assigning it to integer variable. So now let's check it. Will we get any error or not?
Again, we got the error. Using C style typecasting also, we got the error. So using normal case, we got the error. Using C style typecasting also got the error. Then what finally we will think it, we will go for C++ typecasting, which I have written here. That is static cast. So for this style, comment it. See. Now, see here. See here, what I'm doing, I'm using static cast. As you know, everything syntax about it. So this x1 is the expression. This is of the target type. So I'm converting the x1, which is 10, to the my class type, and I'm assigning to the my class object. And again, here what I'm doing, I'm converting the object to my class object type to integer, and again I'm assigning to the integer variable. So this is using static cast. So if you want to do the operations on objects and
Primitive data types. So we'll try it. So will this work or not? We'll check it first.
see, again here also we got the error. So this is the error. Using static cast, using C++ typecasting also we got the error. So what we'll think, using C++ typecasting we got the error, and using normal way C style typecasting also we got the error. So what can we do now? We can understand two things here. So if you want to do operations using object, assigning the object to the primitive data type or assigning the primitive data type to the object, what can we do? There are two cases. Either we need to modify the code which is present in the compiler for primitive data type. Otherwise, we need to change the code which we have written. That is user defined data type. That is my class. My class I have created, right? So we need to change the code in the my class so that it can accept the integer data type and it can accept the integer data type. So what can we do now? So here I have two things. See, I have here conversion constructor and conversion operator. So what actually happens is, see, I'll comment it. Conversion constructor and conversion operator. See, now what actually happens here is now I'm assigning integer data type to the object type, right? My class object type. So this don't think as if it is a constructor. What you will do in a parameters constructor, you will pass a value to the parameters constructor, you will accept it in a constructor, and that value will be passed to the class member variable. So in the same way, this expression totally evokes this function call. What actually happens? This x1 will be passed here and it will assign to this value which is present in the class type. And this expression, this is the object type. Object type, what actually tell here, what you think is, you think that this object is as a function. You are calling a function here in the object and that function call is returning something. If that function call is returning something, it will be replaced here, right? Generally, if you call the function from here, it will return some value. That returned value will be replaced here and that will be stored in the x2. In the same case, this expression will evoke this function. Why it will evoke this function? Because you are writing int here. Because you are assigning it to the integer variable, it will evoke the integer function. What this integer function is doing? This function is returning the value which is of integer type. You can write many functions like this using the keyword operator, and you can write char, you can write double, many functions you can write it. According to the data what you have written, according to that only that function will get evoked. So here it is returning integer value, and this integer value will be replaced here, and it is stored in the integer variable. So now let's check it, we will get any output or not. See, see, we didn't get any error, you observe it, and I'm getting output. See, conversion constructor is called first, conversion operator is called first, and we got 10 10 as output. Why did we get 10 10 as output? Let's check it. See, for this expression, first what did I tell? For this expression, this function is called. So conversion constructor is called first. We printed it. And again for this expression, this function is called, integer function is called, conversion operator is called immediately, and it has returned some value. So for this expression, 10 is stored in the value for this in this value, and for this value is stored in x2. This 10 is printed and again another 10 is printed. So in this way we can say that these functions are important. If you want to do operations on primitive data type and object type, these functions are important. So in this simple way you can do these operations in such way. Now let's understand some more examples in static cast. See, I'm explaining you with multiple examples because the examples are the main thing to understand some topic, right? So that's why I brought you multiple examples and I'm explaining you. See here in this example, I have a base class, and this base class is inherited publicly in derived one class, and this is inherited privately in derived two class. Now one base class and two child classes, one parent, two child classes. So here what I have done, here I have base pointer which is pointing to derived one, which I have created dynamically. So this is okay. Generally polymorphism constant. Base pointer pointing to derived class. This is okay because base is public here. Now let's check it. Will we get any error here or not? I think we'll not get any error because it's general polymorphism content. We didn't get any error here. It compiled successfully. Now what if, observe it clearly, what if in the place of derived one, if I write derived two? Now base class is pointing to derived one, we didn't get any error. It is okay. But this base class is pointing to derived two. Will we get any error here? Let's check it. Will get any error here or not? See, we got the error. What's the error? Base is an inaccessible base of derived two. So what is this error is generally base is inaccessible of derived two. Base is inherited in derived two, but it is privately inherited. As it is privately inherited, we can't access private members of the class.
from outside of the class, right? So that is the way we are accessing this base cannot point to derived to because private members of the class are accessible within the class or we need to use friend function. Without those two cases, we can't access private data members outside of the class. So from outside of the class, what we can see is this derived to, there is no base in the derived to. There is no base in the derived to and we are pointing the base class to derived to. When there is no base in the derived to and when base is pointing to it, it surely will get the error. So this is the case, we got the error. And one more thing, what I am telling is, so we got the error here, right? So what generally people do, we will do C style casting. Using typecasting, we'll check it. Will it give the error or not? Using typecasting. So now again, base class is pointing to derived one. Now what I am doing, let me uncomment it.
Here what I am doing, this base pointer, I am converting, telling the compiler
Same in the previous example, what I have said. I am telling the compiler to forcefully convert the base pointer to derived two type. Derived two type. It is converting into derived two type. I am assigning it to the derived two pointer. So what indirectly what happening? This base is indirectly pointing to derived two class. But here what actually happens? Base 2 is private here. We got the error there. But here we'll get the error or not, we need to check it. That is the same case, right? So now I'm checking it. See, we didn't get any error. Means this is the dangerous case using C style typecasting. As we didn't get some errors in C style typecasting previously, here also we are not getting any error. If we don't get any error, we may think that it is okay, it is successful, and we'll execute it. While execution, we may face some problem. So this is the case. So what I want to tell is, so we didn't get any error here, right? So let's try with C++ style typecasting. In C++ style typecasting, same here I am using a static cast. What I am doing this base class. Again base class is pointing to derived one. I am telling the compiler to convert it into derived two. Base class is converted into derived two and assigned it to derived two pointer. Now let's compile it. Now using derived two pointer, this derived two pointer is pointing to derived one. No,
So now let's compile it. What actually happens? See, we got the error here. Why we got the same error?
what we got here, the same error is repeated here. Base is inaccessible base of derived 2. In derived 2, whatever the base is there, that is inaccessible from outside of the class. Why? Because that base is inherited privately here. As it is inherited privately, we cannot access outside of the class. As it is base is inherited privately, from outside of the class, we can assume it as there is no base in the derived 2. As there is no base in the derived 2, the base pointer cannot point to derived 2. If it is inherited publicly only, we can point using base pointer. If it is privately inherited, we cannot point, right? So that's why we are getting error here. So this is the one more case where static gives you the error compared to system cast.
So we have understood it with multiple examples. Now we'll check where actually static doesn't work. So these are the cases where actually static doesn't work. So I'll explain these cases with examples. So let's see. I have multiple examples here for you where actually static doesn't work. So see here. See, here I have an integer constant variable. I'm trying to typecast it with normal integer variables. Constant variable with non-constant pointer. So here it throws static throws the compilation error. And again I have constant integer variable and I'm trying to convert it into the non-constant reference variable. So again here it throws the error. And one more thing is integer variable we have here and integer pointer we have. And we are trying to typecast the integer pointer into character type. So here again static throws the error here. So these are some cases where static throws the error. And one more thing is here we have volatile variable. Volatile variable we are trying to typecast it using volatile pointer. So here also we'll get the compilation error. So these are some cases where actually we will get the compilation error. Now let's check it where we are getting error or not. See here. See, we got the error here, like integer pointer, constant into normal int, constant into normal reference, integer pointer into character pointer, and volatile to non-volatile pointer. So here we are getting multiple errors. So these are the cases we'll get the error. So this is the end of the video. Hope you understood the topic,
What actually static cast is compared to C casting and C++ casting. Hope you understood it. Everyone please like, share and subscribe the video. Thank you.